right? The 17th one over here, right? They have mentioned what boats can shelter from the waves on the sea in a harbor. Diagram shows a harbor where boats can enter and leave through two gaps in the harbor wall. Here we have the diagram, right? Waves on the sea are diffracted as they pass through the gaps in the harbor wall. Describe how Huygens construction can be used to predict the shape of the diffracted wavefronts. Right? According to Huygens principle, right, any point or each point in this wavefront can be treated as what? Can be treated as a wave source for the secondary wavelets, right? And these secondary wavelets, they interfere or they superpose, right? I can't draw it, right? I mean, exactly in, here and here they're moving, and by predicting the shape, I mean the resultant, by using the resultant wave, we can predict the shape over here, right? When they are moving over here, right? So we have to mention that thing, right? Uh, First, you have to mention that each point on a wavefront, right, treated as a source of secondary wavelets, secondary wavelet, and what these further wavelets interfere, right, or superpose, interfere, or you can write, right, the resulting and the resultant and the resulting wave predict the shape. Well, right here. So the marks are given for this whole sentence, right? For 1 mark, right? For this one, the other one, right? Okay, and you will get the 2 marks. One for this one, right? Here in the part B, optic question, right? The wavefronts in the sea arrive parallel to the harbor wall. The wavelengths of the waves varies as the weather varies. There are identical boats at two positions A and B in the harbor as shown. It's a diagram. As the wavelengths of the wave varies, the boat at position A always oscillates with a large amplitude. The boat at position B sometimes oscillates with a large amplitude and sometimes oscillates with a small amplitude. Right here, explain why the boats oscillate as described. Right, in this case, right here, the diffraction will be like this. Right, I'm not drawing a according to the scale, right? Here, I hope you know that one, right? So then what will happen, right? If I draw the waves, they would be like this, right? Even in here, right? If you take the path difference, let's call here it is L1 or whatever, and here it is L2 or whatever. And if you take the path difference, right? Path difference, that is, if it is equal to what? If it is n equals to n times lambda, n means a whole number, right? Integer, uh, including 0, right? So if it is n lambda, uh, that will cause what? Constructive interference. That will cause constructive interference. So if the path difference is equal to 2n plus 1 over 2 times lambda, right, then it will cause destructive interference, right? Okay. And in terms of radians, we can the same thing. I hope you know that thing, right? If it is what we call it n times, if it is n 5, what we call it is constructive interference. So if it is 2n plus 1 times 5, it is uh, destructive interference, right? So I'm going to use in terms of path, this I mean in terms of lambda, right? In the position in the board at position A always oscillates with a large amplitude, so it is should be what constructive interference at position A. Then the board at position B sometimes oscillates with a large amplitude and sometimes oscillates with very small amplitude. So while it is if it is moving large amplitude, sometimes that should be the constructive interference, right? So if it is oscillating with a small amplitude, so uh, it should be destructive interference, uh, right? And for this one, right, the phase difference changes for the B. So how can we write our answer for the question, right? Because it is a synoptic question, right? So I'm writing over here, right? Waves from each gap, right? They interfere or superpose. We know that thing. We have to mention that one, right? Waves from each gap, right? Superpose, pose, or interfere, interfere, right? And at question A, right? Question A, what, right? There is no path difference or phase difference. Why it is oscillating at large amplitude? So it is constructive interference, right? So I'm writing that one at position A. There is no path or phase difference. Phase difference, right? Okay. Why, right? Because it has a it is moving sorry, it is oscillating with a larger amplitude, which means the position over here is constructively interferes, right? So I'm writing it. So there is constructive interference, constructive interference, interference, right, leading to larger amplitude oscillation. Amplitude oscillation, right? Now you might ask here, then I have mentioned there is no path difference and phase difference, right? Which means, right, as I explained over here, right, it can be either n can be 0, 1, 2, or whatever you prefer, right? If it is a whole number, then it is it has constructively interfered. Then so here what we are considering, even in the marking scheme they have given no path difference of no phase difference, so we are considering n is equal to 0. It is okay if you write it as if it is it should be n lambda, because uh, it has a larger amplitude. It's okay, right? Okay, then here for the question B, right, I'm writing it over here, right, at question B, right, the phase difference, the phase difference, the phase difference varies with wavelength. Why? Sometimes, oh sorry, sometimes it is oscillating with a larger amplitude and sometimes it is oscillating with a small amplitude, right? Difference varies with wavelength, right? So uh, if there is an odd number of half wavelengths, there is odd number of half wavelengths, then what will happen, right? The path difference, uh, wavelengths path difference, then what will happen? There is destructively interference, right? There is destructive interference, right? So you might wonder why they have used a odd number, right? As I explained to you, right, it is I'm writing it over here, 2n plus 1 over 2 lambda. Is it clear my point? Then if it is if you read it as here 2n plus 1 times lambda over 2, right, you can write it as what? If it is a odd number of half wavelengths, right here, if it is a odd number of half wavelengths, and that is the condition for destructive interference, right? That's why they have written as half wavelengths of sorry the if there is a odd number of half wavelengths path difference, right, there is destructive interference, right? Or you can write if they are in antiphase, they should be in antiphase. If you take it in the as in the phase difference, right here, as I mentioned over here, in 5 or 2 and plus 5, if you want it as a current phase difference, then you can write they are in antiphase, they will destructively interfere, right? And for the 6 point, right 6 point, or right, and it should be simple. And there is a whole number of wavelength, and there is there is um, whole number of wavelengths path difference, wavelengths path difference, then what will happen, right? uh, there is constructive interference, there is constructive interference, there is constructive interference uh, leading to large oscillation, right? uh, in this case here I haven't mentioned that leading to small small oscillations. You have to write even that one. I forgot. So if you write this answer, you will get full marks. I will cover the points that they have given marks, right? I will correct, right? Here what you have to mention, the waves from each gap superforce interfere, you will get 1 mark, right? You will get 1 mark. And at position A, there is no path or phase difference, right? For mentioning that one, you will get 1 mark, right? I hope you know, right? If you write all the 6 points, you will get but 4 marks, and 2 marks are allocated for the logical coherence, but you have to write 6 points to get the full mark. So there's a constructive interference one, right? In the point that they have given, 1 mark, right? Yeah, it's better if you find press or something, so that otherwise you will hit 1 point over here and another point over here and another point over here, right? And at position B, right? And here and mark, right? This is for the position A. I'll mark on it, the color of red, yellow. And position B, the phase difference varies with wavelength, right? To mention this one, they recognize it as another point. And here, right, if there is odd number of half wavelengths, path difference, there is destructive interference. But you have to write over here what leading to small oscillations. I forgot to write that down here, that's why I draw a line over here. 1 mark, I mean they recognize it as another point, right? For this one. And the other point is this one, whole number of wavelengths path difference, there is constructive interference leading to a larger oscillation, right? And this is the last one. So if you have written these 6 points with the correct logical coherence, you will get the 6 out of 6.